Welcome to Dysmorphology Basics Part 1b. We are going to continue with definitions, terminologies, and concepts. I hope you just saw Part 1a because it is very useful if you remember the prior contents of the introduction on Part 1a, since we are continuing here in the same direction. Here is illustrated the development of a normal phenotype. A phenotype is a conglomerate of traits or signs. So signs and phenotypes to some degree are synonymous. The genome is the total sum of genetic information. And morphogenesis is its execution through interactions with the environment. If all goes well, the phenotype we call normal. On the other hand, alterations may be due to gene mutations, rearrangements of DNA or chromosomes, and impacts by epigenetic factors, that is, those factors that regulate the expression of genes. Epigenetic factors are not genes as such, but they have impacts on their function. Or environmental factors that also alter the expression of the genetic instructions needed for development. The outcome then is a series of functional or structural signs. In this case, we illustrate with a phenotype of mental subnormality and characteristic friendly behavior, a facies, that is a face that talks to you because concurrently there are features like epicanthic fold, a small nose, etc. So this facies and behavior are suggestive of a syndrome, two concurrences in multiple individuals. But we could add to this other anomalies that it's not the point here to mention. Here is the definition of epigenetics, so please read that at leisure. So if we have a normal genome and a normal environment and a normal epigenetic circumstances, still there are external factors that can deform the morphogenesis. So the deformation is not an expression of an abnormal genome, nor an expression of an abnormal environment in the large sense, but a abnormal environment in a mechanistic, localized sense. For instance, many babies are born with a wry neck, that is a contraction of a muscle. This is an injury. This is a deformation due to an injury to the sternocleidomastoid muscle of an infant. So exogenous factors, and this is then torticollis or wry neck, a fairly common anomaly that pediatricians and obstetricians are quite familiar with. Here is a case of 1 foot with relatively normal morphogenesis and one which is an equinovarus, and here is an equinovalgus. So this may be a deficiency of genetic nature, there's muscle atrophy, or it may be that this was stuck somewhere and pressured before birth so that this foot could not fulfill its morphogenesis. Here is an example of a deformation for social reasons, flat forehead. And here is the papa trying to flatten the head of his son, because that makes them socially advantageous. Note that there are links here that are not active because you're watching a video, but you can go to the CEO or Clinical Eye Opener website in search of active live links. Now, this also brings another point worth mentioning, and that is that many babies have deformed skulls as they are delivered because they are compressed in utero, and that's called plagio. Plagio means false or deformed. So plagiocephaly is a fairly common disorder in neonates, and in most instances it will self-correct because the genome and the environment otherwise are normal. This you can read, and I will move on. And there is a disruption, that is a teratogen. You have a normal genome and you have an alcohol. This is the grandmother of a mother of this child who was an alcoholic. So teratogens, one example is alcohol, another one can be radiation. But the difference here is that radiation will impact the genome and the embryogenesis. The genome, it will attack DNA and cause mutations as well and chromosomal breaks, but here it will irradiate rapidly dividing cells, cause their death, and therefore disrupt the balance of normal embryogenesis. So please read this. Here you have a panel of images to impress upon you the behavioral component of the fetal alcohol spectrum disorder. You know this baby is not happy, neither is this one, neither is this one. They tend to be very, very unhappy children. They cry a lot, they have trouble sucking, and nothing seems to satisfy them. And they have physical features to accompany the functional ones. Watch this lip, no vermilion, that is the pink mucosa, no vermilion, no vermilion, no vermilion, no vermilion, no vermilion. So it's concurrent with the behavior and is consistent across individuals. Also note that they don't have philtrum, that groove in the midline of the lip. So they have a flat lip, flat lip, flat lip, flat lip, flat lip, and flat lip. So now you're beginning to build a syndrome, and in this case you have then the concurrence of 2 signs. You can add microcephaly, 3 signs. You can add narrow palpebral fissures, 4 signs. Here you have a cleft palate, and if that's the only one, it's not part of the syndrome. But if every one of those, or at least half of them, have a cleft palate, you could say that fetal alcohol spectrum disorder syndrome includes cleft palate. So please read. Here we have another panel of images that are somewhat similar to each other. Missing distal aspects of the upper limbs, or phocomelia, phocomelia, phocomelia. This is a 600-year-old image and illustrates a facies that I would say is not normal. It also is suggestive of premature aging, if you like, and breasts that I don't know if they belong to a male or a female. Therefore, if it is a female, they may be hypodeveloped or hypoplastic, or if they belong to a male, they would be a gynecomastia, that is too large. Here is an illustration by Joseph Workeny, the founder of medical teratology. He is the one who proved that environment can cause birth defects, because until then, all the causes that were acceptable to scientists was that they're all genetic. They cannot be environmental. that an embryo is so protected in utero that nothing can harm him from the environmental source. Here is a more recent image. This woman's mother took thalidomide and delivered her with these characteristic anomalies just similar to these. Now, this has additional messages. Here we didn't know if the baby is fertile or whether it can reproduce. Here she's pregnant and we know she has another daughter at home. That is perfectly normal. We know she's intelligent, so we know thalidomide does not impact intelligence. So it is selective. And because it is an environmental factor and she did not consume that, she is not posing a risk to her pregnancies. Following the discovery of thalidomide, which by the way did not exist 500 or 600 years ago, agencies such as the Food and Drug Administration in the United States and other agencies in every country monitor medications to determine if they are safe for the unborn. Why? Because there were many tens of thousands of children with these anomalies in countries where thalidomide was marketed. When the marketing stopped, the epidemic of these anomalies stopped as well. Here we know the etiology must be different. And this is an example where dysmorphic signs, the association of thalidomide with aphases, the association of thalidomide without aphases, are very useful. Here is a very recent report that happens to be our own, underscoring the relationship of radiation to pregnancy outcomes and congenital malformations in a zone polluted by Chernobyl radiation. Radiation is a mutagen. It can change the genes, and once changed, if they are the cause of congenital malformations, there may be many generations that will repeat such events. Radiation can also be a teratogen, and that is, it will destroy embryogenesis to different degrees. Radiation is also a carcinogen, and it may be the cause of thyroid cancer, as it is well known, leukemia, and so on. 30 years later, how is that possible? Chernobyl exploded in 1986. How are these effects perpetuated? The developmental anomalies in Rivne today are still the highest rates in Europe. Not all anomalies, but consistently some specific anomalies. In other words, there is a Chernobyl-Rivne syndrome. What are those? They are blastopathies. Blastopathies meaning early anomalies. Which ones? Teratogens, neural tube defects, and microcephaly, a syndrome we could call the Chernobyl-Rivne syndrome, if so you like. So remember, radiation is a mutagen, changes the genome that may then produce hereditary alterations in human populations for many generations. Radiation is a teratogen. If incorporated into the body of a woman, she will then have high-risk pregnancies because the radioactivity is latched, is hooked, is incorporated in their different tissues. Teratogen is also a carcinogen, so that these exposures to radiation are also exposures to high cancer risk, results in high cancer risk situations. Now we are ready to present a more detailed definitions of a variety of teratogenic impacts on embryogenesis and morphogenesis. In this series of frames, we are going to illustrate contrast between notions of polytopic sequence, syndrome, associations, and so forth. It is best that you read this rather than me interjecting comments. I will come back nearly the end of this module, and in the meantime, read these slides by stopping the motion if you have to. Welcome to the end of Part 1b. I'm sure you will enjoy much more the modules that follow because they include videos of patients and a plethora of provocative images. And until then, I extend to you my best wishes.